I'd like to introduce our speaker, Robert Villa. He's been, like many of us, a lifelong cactus and succulent enthusiast, but he started, like many others, in herpetology. He is presently the community outreach assistant at the Desert Laboratory on Tumamoc Hill. He has edited and written many technical papers. He was mentored by Mark Demmett, who many of you know, and I could go on and on and on, but his speech is far more interesting. So with that, I'll turn it over to Robert and enjoy.
Thank you all. Thank you very much for having me. It's a honor and a privilege to speak to the CSSA. Um, can you all see?
Yes, I think you have to take full screen on that.
Okay.
You got it.
It looks
You got
good
it.
now.
Yeah.
I'm gonna turn off my video because I'm gonna do a lot of turning away from the screen. Um, and it'll look a little awkward. Let's see. I think stop video, right?
It's on the lower left, second indent. See the camera?
I'm gonna do this real quick. There, okay. And you, okay. Are you all be able to see the screen or the slideshow mode?
Yes.
Okay. Well, Skugdash, this is how we say hello in the Autumn language here in the Sonoran Desert. Skug means good, and Dash means sun or day. Um, we are I'm coming to you from Tumamoc Hill or Chemamak Doag, which means Horned Lizard Mountain in the Autumn language. It's a research facility and significant cultural site here on the very edge of Tucson. It's sort of like a central park in a way. Um, every every background in Tucson at some point visits the hill, um, and depending on the time of year, between 500 and 2,000 people, up or near 2,000 people, will visit the hill to be surrounded by this beautiful Sonoran Desert. Um, and this provides both a great challenge and also a great opportunity to engage people with the biocultural and biodiversity of this incredible place. And before I go any further, just to let you know the structure of my talk, the first part is going to be a little on the history of the laboratory and how it's the longest continually operating research uh, field research station in the world, or at least one of them, and its relation to succulent plants and desert ecology. And then I'm just going to give you a whirlwind road trip from the driest part of the Sonoran Desert to the wettest. Tumamoc Doag, or Tumamoc Hill, has been inhabited for thousands of years, and one of the most prominent archaeological features of the hill are these rock walls for a stratified community of people with nobility at the top and less noble towards the bottom. People grew arid-adapted crops. Maize and agaves feature prominently. The Huhukam, which were the first people to do the earliest agriculture in the Tucson area were growing what we call Hohokam agave or Agave murphyi. There are at least 6 other agaves which were engineered by ancient people for eating and fiber production. And this is the most famous one, Agave murphyi, and it was grown on the lower slopes and foothills of the mountains through catching sheet flood runoff. The pups were placed in rock mounds that would trap water when it would rain. And the people would eat these agaves just prior to their flowering, when the core or the center of that plant was filled with delicious tissue, sugar-rich tissues. And you'll see, if you'll notice, maybe on the lower right of this plant, there's a white rock there. And I'm willing to guess that that is a rock which got turned into pumice over the course of heating the hearts in underground ovens at very high temperatures. So this was the first very technical and advanced for its time agriculture in the region of a succulent plant. People really depended on this plant for sustenance. I could go on, but that's a whole nother presentation that I'd be happy to give to you all. Fast forward quite a bit to the Carnegie Institution of Washington. Andrew Carnegie, wealthiest person on earth, was a philanthropist. I tell people he was the first Bill Gates of his time. He had an institute, and Frederick Coville was the head of the USDA and Forest Service. He was also on the one of the science committees of the Carnegie Institute. And he decided, and some other people decided, that there needed to be a desert laboratory to understand how desert plants exist in extremely dry and hot conditions, because for a number of reasons, agriculture and westward expansion, a civilization into the deserts of North America. He got together with Daniel T. McDougall, who was director of laboratories at the New York Botanical Garden, and they decided that Tucson and Tumamoc Hill would be the place to build it after a search of different desert regions. And so by October 7th, 1903, the first building, the building that I'm sitting in, was finished. The windows, the 3 windows on the left that you see, that would have been the director's office, and today is the library. There is a photo processing darkroom with red glass on the opposite end of the building. The tiles were brought in from New York. They're slate rock, slate. And there's Daniel McDougall, who would go on to be appointed the first director. He left his post in New York. You know, Daniel McDougall was on the vanguard of plant physiology. He held posts at Tübingen and the Max Planck Institute, studying photosynthesis and chlorophyll. He was on the cutting edge of plant science at the time. And the Desert Lab at that time was also a state-of-the-art facility, and it was funded by Andrew Carnegie. This is a photograph of the library, which today is our classroom for visiting groups of people. Here's a photo which had to have been after 1906, because that was when the greenhouse was completed, and I would hazard to say that it was probably Arizona's first greenhouse. So there's an apocryphal tale that one day Daniel McDougall's old boss at the New York Botanical Garden, Nathaniel Britton, had written to Andrew Carnegie Carnegie had also helped with the New York Botanical Garden, and there were already some saguaros in the New York Botanical Garden greenhouse. Nathaniel Britton and his research partner Rose, and I forget his first name, but they of course are famous cactologists. They wrote the great monograph, the Cactaceae. But prior to this, he wrote to Carnegie saying, you need to visit the facilities that you helped to build, or that you built actually. And by the way, I've decided that the saguaro belongs in its own unique genus, and that it's the only species within its genus. And Andrew Carnegie, not being a botanist, had no idea what that meant. He thought maybe some individual plants or cabinets at the botanical garden had his name on them or been dedicated to him, or a building, but he really didn't understand. And the story goes that he came to Tucson and he visited the lab and was fascinated and amazed by the Sonoran Desert, and that this cactus now bore his name, Carnegie gigantea, and he has rumored to have asked, well, how could you overlook such a conspicuous plant? Well, they said, no, Mr. Carnegie, we actually just reclassified this plant, and it bears your name. And that seems to have maybe not met his, maybe was unimpressive to him. And the story goes that he got mad, and he thought they were trying to ply him for more money, and he turned away and never came back. But in actuality, he still was confused. He didn't really understand the significance of the naming. But he here's the original description. After this publication came out, the same year that Nathaniel Britton wrote to Carnegie, Britton and Rose received funding for their monograph on the cacti for 5 years. So the story, I think, is not entirely true. Nathaniel Britton and I think Jonathan Rose got a lot of money to complete their monograph. The type collection, as you can see, is here at the Desert Laboratory. The type specimens, let's see here, is surrounded by typical specimens of this unique plant. And of course, here's the first volume, and it's published by the Carnegie Institution of Washington. And you'll see that Carnegie's institution financed or published several important botanical things. Also in 1912, Rose named a Sonoran Desert endemic plant in its own genus, Tumamoca, and he named it after Daniel McDougall, Tumamoca McDougalli. And I will fight to my death that it not get relocated to Iberville. Not really, but I think many botanists have now synonymized Tumamoca with Iberville. But it's a really unique geophyte cucurbit. It's dioecious, which means that it has male and female plants. And this guy, Frank Reichenbacher, who's an associate here at the Desert Laboratory, published the culmination of his life's work studying this plant. It's in the most recent Hazeltonia. I'll encourage him to speak at the meeting here in Tucson, or even give you a talk, although it's quite technical, but it's a fascinating story. And he recently came out with a paper on the monsoon based on saguaro data, cyclical monsoon season. So here's the greenhouse. This is what it looked like back in the day. What I find really interesting is we have a lot of tropical plants from the southern edge of the Sonoran Desert. We have some cacti, but look at this. Even back then, people were growing pet aloes, and I think this pretty much looks like a begonia here. So yeah, and we have saguaro rib shade structures and with cholla skeleton uh, to hold it. And I'm gonna guess this is some sort of Matelia. Um, and this is what it looks like today. It's no longer a high-tech research greenhouse, but I use this as a display of succulent plants from around the world to inform people what is a succulent plant. Um, so we demonstrate things like convergent evolution, that cacti are succulents, but not all succulents are cacti. And of course, because Mark Dimmitt is in Tucson, we have to have some examples of adeniums. This is Adenia spinosa, some type of Oreocereus, I think, or Cleistocereus. This is Yucca angliciana. Um, yeah, and a nice parodia that flowered recently. Godfrey Sykes, he merits a whole talk just about himself. He was living in Flagstaff. His father was a painter and an architect for the Victoria and Albert Museum. But Godfrey and his brother left. They came to Arizona for many interesting reasons. But long story short, Daniel McDougall was on his way home from Death Valley, and he was camped, and he woke up and he realized that his guide had had stolen most of his stuff. And he came wandering to the house of Godfrey Sykes. This was outside Flagstaff. And Godfrey fed him, got him on a train back to New York, and they became really good friends. Well, when Daniel McDougall became the first director of the Desert Laboratory, he wrote Godfrey and he invited Godfrey and his family to come to Tucson so that Godfrey could be the superintendent of the laboratory, to maintain the vehicles and the pack animals. And he built this shack, this tool shed, but look at, there's a boat there. The reason he built boats, he was really good at building boats, was he explored the Colorado River and the Delta. And that would prove very useful because when the Salton Sea formed, he was the first person to circumnavigate the Salton Sea. And of course, the scientists wanted to know what happens when a sea or a big inland basin gets filled with water over the course of 2 years. Godfrey Sykes is also the person who named the Boojum tree the Boojum tree. And that, like I said, is a whole nother story, a whole nother talk. And we're actually working on a film about it. But here he is. You can see him in the Colorado River Delta. The second director is Forrest Shreve, and he was the first person to map the Sonoran Desert based on its vegetation. And this pretty much still holds true, except that this region here is now not considered a subdivision of the Sonoran Desert. That's thorn scrub. It's the transition from Sonoran Desert in the north to the dry tropical forest here in the south. And here he is. The Carnegie Institute published the first volume of his Vegetation of the Sonoran Desert. And volume 2 that I know of was not published by the Carnegie Institute. I think that would come out later on when Ira Wiggins would do volume 2, the flora, which is different from the vegetation. So these publications owe their genesis to the funding here at the Desert Laboratory. The Sonoran Desert is the most biodiverse desert on Earth. It's bounded by many biotic regions. And this is just a rough estimate of species and area. And the Sonoran Desert here is this yellow that you see that goes from the peninsula to the mainland. This is Effie Spalding, the son of not the son, the wife of Volney Spalding. She and Daniel McDougall published the first paper associated with the Desert Laboratory, observing how saguaros expand and contract as they drink water. And these are the contraptions and tools that they used that were state of the art back then. This little organ pipe here this photo was taken around 1914. It's a giant, massive plant now. It's still here to this day. Volney Spalding mapped the movement of desert perennial plants or annual plants, their canopies, and his plots are still in active use today. The scientists here, they did lots of great things, but they looked at the life zone concept in the Catalina Mountains, and they took this struggling hobbyist magazine, The Plant World, and by 1920, they had turned it into Ecology, one of the most important journals in science today. They started publishing all their research they were doing in Plant World, and they helped make the Ecological Society of America. And to this day, we continue to publish in that journal. Volney mapped every saguaro on Tumamoc and Sentinel Hill back in 1908, as indicated by each little green dot. And in 1964, Ray Turner established a permanent saguaro series of census plots, which we'll get to in a little bit. But he also pioneered the idea of repeat photography with Rodney Hastings, and they published this book called The Changing Mile. And this is a very famous sequence from that series. This is in what would be Saguaro Park East back in 1935, 1960, and 1998. And you see a very steep drop in the saguaro numbers, and there was a reason for that. There was a really harsh winter. Frost is a limiting factor in the distribution of saguaros. But what you don't see in this photo is a cohort of baby saguaros that have been insulated and protected by all these palo verdes and nurse plants. But the Desert Lab the Desert Lab helped Ray Turner develop these repeat photography sites all over the Southwest. Peter Breslin is a postdoc here at the Desert Lab, and he did our most recent census, but he just received more funding by Bob Webb, who made a very generous endowment to the University of Arizona to fund postdocs, a Ray Turner postdoc program in perpetuity. Ray Turner was the advisor of Bob Webb, and Bob Webb is very fond of Ray Turner, almost like a father figure. And he went on, Bob rephotographed the Stanton expedition of the Grand Canyon. There he is doing that work. And of course, Bob is polymath, I would say, very bright. And that's he and Tony at the world famous Arid Lands greenhouses. He, along with others, rephotographed the pair of photographs from The Changing Mile in a book called The Changing Mile Revisited. It's a wonderful book. So there are some connections to the Desert Lab and many important cactologists and succulent plant people in the CSSA. In 1956, the lab was acquired by the U of A. In 1966, the road is extended, and the observatories at the top were used to map the moon for the first Apollo mission. It's a National Historic Landmark, which means, and an archaeological site, which means that any dirt moving or any architectural modifications or repairs must go through a lot of red tape. And finally, one of the most interesting history of research here at the Desert Lab are packrats. More specifically, not the fact that they're pests, but that they poop, and their poop preserves plant material from thousands of years ago. What you're looking at here is several thousand years of continual occupation and use of this packrat latrine, which preserved plant material. And scientists realized that you could look at material, from the oldest down here to the newest here on top, and determine the vegetational history of the Southwest. And there's Julio Betancourt, Tom Van Devender, another one of my mentors. And then there's Paul Martin here, Tom's advisor, lovingly looking at a big pile of packrat poop. And they published this really great book on packrat middens, the last 40,000 years of biotic change. Paul Martin was a brilliant scientist. His grad students studied palynology, paleobotany, paleontology. They all had different disciplines, but they had unique ways of trying to understand the past. And packrat middens were kind of the nucleus, one of the main things of all of this. This is a giant ground sloth dung ball, which was recovered from Rampart Cave in the Grand Canyon. And we know that its dung is filled with globe mallow and ephedra. So you had a giant 8-foot tall sloth who was munching on a stimulant, ephedra, and climbing up the walls of the Grand Canyon and sleeping in caves with extinct mountain goats. So this was really quite an exciting time. The 60s and 70s were exciting to be here at the Desert Lab because it was corroborating the independent fields of tree ring dating, glacial coring, volcanic CO2 emissions, and things like that. Tom Van Devender is now a prominent botanist in the Sonoran Desert and northwestern Mexico. Here's Paul Martin. He also did his PhD on amphibians and reptiles, but he went on to come up with really controversial and giant ideas about why giant animals went extinct when humans first arrived in North America. And finally, we have a fossil collection which represents a period of time when people were interacting with giant mammals. So there's that, and now we're gonna go. I see it's 10:36. We're gonna go on a wild tour of the Sonoran Desert. Why is it the most biodiverse? Well, there's two big reasons. One is that the Gulf of California, you have birds, for example, you have seabirds which are eating seafood, and their guano fertilizes the Sonoran Desert plants, for example. So you have a trophic link between marine life and desert life. A great example of this is Zostera, marine grass. And this is a slide from a sea turtle talk that I give, but it's the only marine grain, and the indigenous people of the coast, the Kumkak or the Seri people, utilized this grain. And along with sea turtles, which they ate, the sea turtle, green sea turtle was like the buffalo for these people. They made flour from the grains of the seagrass, and they make the only known marine bread. So this is what we mean when the life of the ocean is inextricably linked to the life on the land. And the other link to the biodiversity of the Sonoran Desert with the ocean is the fact that the Colorado River drainage has been eroded by water over the course of millions of years, and it's been dumping into the northern Gulf. You see how shallow it is up here, and then it begins to drop off very abruptly. This creates warm water because it's shallower. And in the summer, when tropical storms barrel up the west coast of Mexico, they would peter out, except that the humid air perpetuates or creates a separate storm system called our summer monsoon season. And this is what the vast majority of organisms in our desert have adapted to. The Baja Peninsula was attached to the Mexican coast. Cabo San Lucas was nestled right in the Puerto Vallarta Bay there, and it's been rifting northwestward along the where the Pacific plate meets the North American plate, as it's subducting, this peninsula is moving northwestward between 3 and 10 millimeters per year along this giant fault line. And this is a kind of a good visual about that connection between the ocean and the desert. So as this peninsula has been moving in that direction and the river has been carving out the Grand Canyon, all this sand is being deposited up here. This is actually the old mouth of the river, the old delta, and it's just been moving northwestward ever since. And there's still fossil water that comes up into these regions. There are salt pilgrimage sites for many indigenous cultures will have walked to this area to collect salt. Some of the earliest maps, accurate maps of the world, depict two Red Seas, the Gulf of Arabia here and the Gulf of California. As a matter of fact, the Spaniards called it the Ruddy Sea, or the Mar Bermejo, because all of those red-colored sediments were coloring the Gulf at that time. These are the tallest dunes in North America, up to 500 feet tall, and it's still red. It's still ruddy. And basically, when you're here on the beach, you're standing on the Grand Canyon and all of its tributaries. It's just been deconstructed. This is 60 cubic kilometers or 14 cubic miles of sand that extends all the way up into the agricultural valleys of Southern California. This is the hottest, driest portion of North America. And it's quite an amazing spot. If you watch the BBC series Green Planet, the Desert Worlds episode was partly filmed in this area for the wildflower sequence. It's just very austere, but we still have plants, geophytes. This is an ajo lily, Hesperocalis undulatus. And the plants are shaped by the sand. They're quite beautiful. And there's one in flower. This will give you an idea of the size they can attain. Here on the right is Triteleopsis palmeri, another beautiful little geophyte. And this was the super bloom of 2017 or 18, I forget. It was spectacular. I doubt that, I'm not sure if I'll ever see such a bloom in my life. But, the austerity of the landscape really, highlights the uniqueness of these plants. This is a creosote bush, and I would not be surprised if this creosote bush were over 100 years old or more, but you can see how it looks like it's walking because the sand has been continually eroded out from under it. The Pinacate volcanic shield is a geologically unique part of North America. I call it North America's beauty mark. You can see it from space. And it is very geologically active until between 1,000 and 500 years ago, based on indigenous oral stories. And you can see how we're starting to notice, we're starting to notice heat stress with climate change on our native plants. It's an emerging field of study. This is Echinocactus polycephalus, one of my favorites. And this is what fall colors looks like on Ocotillo, which I find so beautiful. This tree, this is ironwood, and it's a natural bonsai. It's maybe about 7, 8 feet tall, but you can see part of it is still alive. Tells you how hot and dry it is. Archaeologists often date sites based on the charcoal used by the people of an area in a spot. And in this particular area, they were getting carbon dates that were 100 or more, 150 years older than the site should have been. And the fact is that it turned out that the people were using dead wood that was already well over 100 years old to make their fires. So these are very long-lived plants that also provide shade and shelter for succulent plants. The shade they provide has a significant amount of cooling and some modicum of humidity for baby cacti. This is a saguaro in a family, in a grove of bursaras and Nolina bigelovii. Again, these plants may be over 100 years old just based on how little water they receive. And you can see even there's some mortality associated with even these younger plants here. Bursera microphylla and these giant massive ocotillos. They're quite impressive plants. This is a curious plant. This is Cochimea and tetraancestra, the cactus formerly known as Mammillaria tetraancestra. And there are these giant craters in the Pinacate. This happens when magma meets the water table and produces cataclysmic explosion. This was a cataclysmic steam bomb that happened millions of years ago. And from the rim of this crater, you can see this silvery line here. That's the northern Gulf of California, right there. It's a magnificent place. And of course, the black rock really highlights the beautiful lichens and things like this. So here's a great contrast of these two very different geological events. Moving up higher in elevation towards what we call the Arizona upland subdivision of the Sonoran Desert, we get snow. This is here at the Desert Laboratory. Tucson sits at the confluence of the southern edge of the Rockies, the southern edge of the Mogollon Rim, and the northern edge of the Sierra Madres. You can see here in this photograph, if I can see my mouse here, there's even some brittle bush flowers, which are being covered in snow here. I call this the receding hairline of the tropics. Here on the left, you have Erythrina flabelliformis, which is a tropical plant at its northern edge. It's on the south edge of a boulder, which stays hot in the wintertime, and it protects the root ball from frost. And it comes back as these little wands, and it flowers around now. The boulder also concentrates rainwater when it falls. It's a natural sort of little protective microhabitat for this tropical plant. But as you move south through the Sonoran Desert towards its ancestor, the dry tropical forest, the winters get warmer, the summers are wetter, and finally you have this massive tree in the tropical deciduous forest, which is the progenitor to the Sonoran Desert. Here at between Navojoa, Sonora, and Alamo, Sonora, are some of the southernmost saguaros, these little green sticks sticking out of the dry tropical forest. But even as far as, less than a day's drive south of the U.S.-Mexico border, we have jaguars. And indeed, we have jaguars that live, at least one jaguar that currently living in the United States. This is a camera trap image of a male jaguar with a desert tortoise in its mouth. So this gives you an idea of the confluence. It's not just the receding hairline of the northern tropics, but it's a convergence, it's a mixture of species from really arid places and really tropical areas. Here again, the Desert Lab comes into play. Howard Gentry, who's the father of agave study, was the first botanist to explore the Rio Mayo. And Forrest Shreve wanted him to write his dissertation here at the Desert Lab on the Rio Mayo plants, to understand the origins, the botanical origins of the Sonoran Desert. He was a poet, and in his description of Ipomea arborescens, a succulent tree, he described it as a spectacular tree with smooth white-gray bark like the hide of a hippopotamus. Apparently, he's met a hippopotamus. It flowers in winter when leafless, holding a high, thin spread of white corollas like stars against the morning sky. These stars soon fall upon the ground where the deer eat them. So he was quite the romantic botanist, and he had a high amount of respect for his indigenous guides. And when he found a new species of Caricaceae, a papaya relative, he gave it the specific epithet of the indigenous name that they give to this plant. This is Harilla chocola. It's a geophyte papaya that is relished by the indigenous people in the area. He also named this agave hyboli, and it's a funny story because I think it's the only plant whose botanical epithet is in Spanglish. He had a guide that was taking him up into this remote regions of the Sierra Madre, and he said, what do you call this plant? And he goes, that makes good hyboli. And he named it agave hyboli. But what he didn't realize was that when he came back to visit the area, what his guide was trying to tell him is that he had lived in Los Angeles and worked at a bar and was familiar with highball cocktails, and that the mezcal that they made from these plants, they would make highballs with. And so the name sticks to this day. It's agave hyboli. Is trying to say highball. The progenitor to most of the peppers that you eat and buy in the store today come from this plant, Capsicum annuum. And the earliest description, of written description, is by a guy named Ignaz Pfefferkorn, peppercorn. He said, the tears started to come. I could not say a word and believed I had hellfire in my mouth. However, one becomes accustomed to it after frequent bold victories, so that with time the dish becomes tolerable and finally very agreeable. But this is the wild ancestor to many of the chilies that you eat, bell peppers, jalapenos, and such. And finally, at the southern end of the Sonoran Desert, where it peters out, it goes into thorn scrub and then finally into tropical deciduous forest. And we have things like Pereskiopsis and Pereskia, probably what early cacti looked like in the North American continent. As the mountains rose up in North America, the Sierra Madre and the Rocky Mountains, it disrupted the atmosphere. It became, it went from being flat and temperate tropical forests to creating deserts where rain could not reach the other sides of these mountains and created deserts. And so what happened was a lot of these trees decided to drop their leaves to store energy during the dry season. It went from being rainy all the time to only being rainy for a part of the year. And so the cacti went from looking like this, and they had to change their body form to being spiny water balloons. But on top of that, the canopy of the surrounding forest often obscured them from sunlight, which meant that they had to bloom and fruit when the forest is otherwise dormant, so that their flowers could be visible to pollinators and their fruits could be visible to things that would distribute the seeds. And that still holds true today. In the Sonoran Desert right now, the saguaros are in full bloom, even though there's nothing that's hiding their flowers. They're the tallest tree in the canopy. But here, this is a photo from April or May, probably May or June, because there's fruits on this plant in Alamos in the dry tropical forest. And here's the same photograph in the rainy season. So those seeds get pooped out right on time for the monsoon season to germinate those seeds already in their little bit of manure. Again, dry season. You can see the organ pipes here in the understory, and then they're completely covered by the canopy. So this geological event really shaped the way cacti evolved their body plan and their phenology, their reproductive patterns. This is April and July. April and July. Actually, from where I took this picture is Dioan bovidesii, a cycad, which was described in 2017, I think. These are some of the most rugged areas of Sonora, only accessible by river. And we see at least in Tucson, very common, popular landscape plants growing in their native habitat, which is vertical cliffs. This is Agave vilmorinana. Here's Hectia montana. Here's Stenosirius thurberi. And one of my favorites, I love succulent trees, pachycols. This is Plumeria rubra at its one of its northern edges here. And these were only photographable by floating down the river. It's pretty marvelous. Here, that might be a bursera, perhaps, or a lysoloma. And here's a very famous popular plant. This is Ficus petiolaris. It's basically almost an epiphytic tree. Its roots are climbing over the rock, trying to reach the moist areas. You can see even this frost damage from probably around 2011. There was a major frost that came through. Here's a beautiful brahia, not brahia, it's Sabal urusana. And some of the trees also do this flowering ahead of the rainy season. This is Tabebuia, relative of Jacaranda. And we have some evergreens where they're in the stream bed, where there's permanent water. We're running out of time, so I'm going to sort of go through here. When you're at the southern end of the Sonoran Desert in the dry tropical forest, there's only 2 trees which complete the 4th canopy layer, which is needed, one of the technical designations of a true tropical forest. There's 2 understories and 2 canopy layers. And this is Albizia sinaloensis and or Conzadia multiflora. They're the tallest trees, and they help meet the technical requirement for tropical forest. And yet here we have cacti growing in some of the wetter thresholds of their needs. This is a white-fronted Amazon on top of Jatropha melacophila. And in some of these canyons, it's dark enough that sunlight can't penetrate really well. This is Ficus cotinifolium. Well, I can't tell what species, but to just give you a size, I'm 5'3", and I'm standing right under the buttress of that tree. Ceiba esculifolia. This is the northernmost population of coca, erythroxylum. This is Bursera cimaruba, giant succulent tree. I guess you could say it's the North American equivalent of our baobab, or of the baobab, or maybe ceiba might be that as well. Wild avocado, Persea podidinea. We have epiphytes, which are also succulent plants. This is Laelia ellersiana, or such. These pseudobulbs are water storage organs. So, but it's humid enough that their roots can grow on rocks and trees instead of the soil. And these are really cool. This is a Cainocereus hurii subspecies gentrii growing right next to air plants. And here's a succulent orchid, formerly known as Oncidium ceboletta, a rat tail orchid. These are succulent leaves. And the barrel cacti, this is Pherocactus pottsii, growing on vertical rock walls because it's the only place they can get sun. Otherwise, they'd be shaded by the canopy. And here's the same Echinocerius blooming, and it's rupicolous. It hangs over cliffs, and it's pollinated by hummingbirds. Look at how tubular that flower is compared to most Echinocerius. So it's really quite a wonderful adaptation. Here's some more massive barrel cactus growing on rock walls next to a tank bromeliad, Tillandsia cretacea. And this is, we thought this was an undescribed species of Gonolobus, but it's Gonolobus planiflorus. It's really a neat, it's not a geophyte or any succulent, but it's a cool species from the area. In this area, we have tropical palms next to pine trees. This is an oak right here. It's quite the wonderful clash of vegetation. There are some 15 types of oaks. This is a willow leaf oak here. This is a hand basin oak, Quercus tarahumeri. Many cool oak species. This gives you an idea of the size of the leaf of this oak. Quite wonderful. Wild cinnamon, Cinnamomum hartmanni, ginseng relatives, Oreopanax. And this is a new species recently described, Dendropanax. And of course, when you're around these trees, you kind of are tempted to climb them. It's quite a wonderful, wonderful spot. But with that, I will leave you. We're at the 11 o'clock mark. This is a spot in the Sierra del Rosario during sunsets. They're quite remarkable, and this is looking the opposite direction towards the sand dunes in the early evening.